All right, this is to finish up some of the pieces from the 4.5 notes about how to find an inverse using an augmented matrix. I'm going to do a couple of these on the video, and then we'll save a couple of them to do together in class before we head into the 4.6 material. So it says, when it comes to finding larger inverses, a system of equations could prove more difficult. Rather, we can use these augmented matrices that we've been learning about. So notice that they said form the augmented matrix. So you take the matrix that you were given, M, A, B, whatever they're calling it, and you put on the other side of the kind of, remember, the straight line, which we kind of think of as an equal bar, we put that as the inverse matrix. Now, if our M is a 2 by 2, we need the identity matrix that's a 2 by 2. If our M is like a 3 by 3, obviously we would be using the 3 by 3 identity. We use row operations to transform it. So we're going to, try to get our identity over here on the left side. That's kind of the goal. And then the matrix you end up with on the right side is actually the inverse of your original matrix. So I'm going to show you how to do this with a 2 by 2. I'm going to do one example of that on this video and one example of a 3 by 3, and that will leave us with a couple versions that we can look through in class as well. So let's start with this first one. So let's say this matrix was called matrix C. So our first step is to form, remember, the C bar I as an augmented matrix. And the goal is, after we use our row operations that we've learned about in the past, we're going to switch it so that the identity is on the left, and then the inverse of C, if it exists, will be on the right. That's the goal. Okay. So let's look at this matrix. So we have 3, 1, 5, -2, put our bar, and then the identity matrix, since this is a 2 by 2, is 1, 0, 0, 1. Remember the diagonal ones with 0 everywhere else. The goal is to get 1, 0, 0, 1 on the left side. And the way we do that is by the row operations we learned when we were solving systems of equations. So we're going to take 1/3 of that first row. So, or in other words, think about it as dividing it by 3 all the way across. And that's going to give us a 1 in the top left spot like we want. So that'll be 1, 1/3, our bar. And then we have another 1/3 because you're dividing 1 by 3 or multiplying 1 by 1/3. And then times 0, it'd be 0. Nothing has changed yet on our second row. Okay, so that's where we're at so far. Now we're going to use row operation combinations, remember, to get the 0. We're going to zero out that 5. So we need to take our new row 2 is going to be, you always use your pivot, your 1. So we're going to do -5 times that row 1 element plus our row 2. And remember, if you need to, write every single one of those operations out. You can write -5 times 1 plus 5, -5 times 1/3 plus the -2, -5 times 1/3 plus 0. In fact, just for this first example, I'm going to go ahead and we'll show all that work. So -5 times 1. So remember, I'm just multiplying it times everything in row 1. -5 times another 1/3, -5 times 0. So that's all the row 1 elements. And then we add to that all the row 2 elements in their, remember, corresponding orders. Okay, so what we're going to get is we still have our top row, 1, 1/3, 1/3, 0. The second row is going to be 0. This is -5/3 plus a -2. So you want to get your calculator out for that. I ended up with a -11/3 when I added those together on my calculator. -5/3 plus 0 would just be -5/3. And 0 plus 1 is just going to be 1. Okay, so we have got that first column to look like the identity matrix in our left side of our bar. Now we're going to move on, and we're going to work on that, getting a 1 where that -11/3 is. So anytime you're dealing with a fraction and you want it to be a 1, you just need to multiply that row by that reciprocal. So if we take -3/11, because that's the reciprocal of that spot we want to be the 1, and multiply it times row 2, that'll give us the 1 we need in that correct location. So a top row is not changing right now. We're just focused on second row. So 0 times anything is 0. -11/3 times a -3/11 is a 1. And we did need it to be negative out here because negative times negative is a positive. Negative 3/11 times negative 5/11 is actually positive 5/11. And you can check that on your calculator. Negative 3/11 times 1 is negative 3/11. Okay, so there's where we're at so far. So the only thing left to accomplish our goal that we set at the top, remember this is the goal up here. We want to take this to this, is we need to get a 0 in that 1/3 location. And we use, remember, our 1 in that second column, that's our pivot. So row 1 is going to be replaced by, we're going to do negative 1/3 times that element plus, oh, sorry, that's supposed to be row 2, plus the row 1. So negative 1/3 times 1 plus it to 1/3 gives us a 0. So we're going to write out all of our calculations on this. So negative 1/3 times 0 plus 1, negative 1/3 times 1 plus 1/3, negative 1/3 times 5/11 plus 1/3, negative 1/3 times negative 3/11 plus 0. Okay, so again, you'll want to use your calculator for a lot of this, but our second row is the same as it was. Okay, so row 1 is going to be a 1, a 0, because that was the goal we were shooting for, and we've created that with those operations. Then we're going to have negative 5/33 plus 1/3. When you add that together in your calculator, it should auto reduce it. It comes down to 2/11. And then this one is just going to be 1/11 because the 3's are going to cancel, and it's a negative times a negative plus 0. So that's 1/11. So notice I have my identity here, which means this is C inverse. So we can actually rewrite that. The inverse of C is 2/11, 1/11, 5/11, and negative 3/11. So that's what we were searching for. Now, remember in class, we learned the determinant method of figuring out the 2 by 2 inverse. Remember, we would have done the diagonal. 3 times negative 2 is a negative 6 minus the 5, because it's 1 times 5. So that'd be negative 5. And so that's negative 6 and negative 5. That would have been a negative 11. So remember, we would have multiplied negative 1/11 out front, and then remember we learned that you switch the 3 and the negative 2 switches places, and the 1 and 5 just change signs. So it'd be a negative 1 and a negative 5. And then remember you multiply that negative 1/11 through, and that gives you exactly what we got here. So yes, the determinant method is the quickest, but again, we were only learning that for the 2 by 2s. So I'm going to save this one for class so that we can practice doing this together. We don't want to go completely cold turkey on that. We want to do it together a couple times. So we're going to do the 3 by 3. We're going to do one of these, and that way we'll have one to do in class. So let's look at this first one. So similar idea. Let's call this matrix F. Okay. If we have matrix F and we set it next to the identity for that size, our goal is through row operations. We're going to get that to be the identity on the left, and that would then be the inverse on the right. Now that's if this works. Now, if you can't get the identity on the left, that means you don't have an inverse. So as long as we're able to get the identity, which is that diagonal of 1s with 0s everywhere else, then we know we have an inverse, okay? So let's start off with this one. Now, I did make the first column a little easier on this one because we want to be able to do these a little quicker and not have to spend too long on them. So here's my identity. Notice it's 0s with a diagonal of 1s down from left to right. Okay, we already have a 1 in the top left corner of our left side, so that's good. We don't have to do anything to adjust that position. We have a 0 underneath it for the second row, so that's good. We just need to 0 out that 2 there, and then that will make that identity column will be swapped to the left side for that first column. Okay, so we're going to do row 3 is going to be -2 times all the row 1 elements, because that's our pivot element in that column, plus the row 3. So row 1 and row 2 are just coming over as is. They were already set up the correct way. Now row 3 is -2 times row 1, so that's -2 plus a 2 would be 0. That'd be a +2 when we multiply it by -1 plus a 3, so that's going to be 5. Negative 2 times 1 is negative 2, plus 0 is negative 2. Then we have negative 2 times 1 plus 0 is negative 2. Negative 2 times 0 plus 0 is 0. Negative 2 times 0 is 0, plus 1 is 1. So there's my first row operation change. So now column 1 on the left side of my augmented matrix is the column we expect to see for the identity. Now we're going to move on to working with the second column, which means we need a 1 where that 2 is. Okay, so my directions here are that I'm going to take and multiply row 2 by a half, which remember just means we're kind of cutting everything in half. Okay, so we'll have a 1, negative 1, 1, and then 1, 0, 0 still across the top row. If we take half of everything in row 2, we're going to get 0, a half, or excuse me, 1, because half of 2 is 1, negative 1 half, 0, 1 half, and 0. Bring across row 3. Okay, now we're going to use that pivot element right there, that 1, to clear out the 0 and make zeros above and below it. So for row 1, we're actually pretty good. We added those together exactly as they are. So if we take our row 2 and add it to our row 1, that already zeroes out because they're opposites of each other. But for row 3, we have to get rid of a 5. So we're going to multiply row 2 by negative 5 and add that to the row 3. Okay, so let's do our top, let's first of all bring over our second row because it's not changing. And then we're going to multiply, actually for row 1, we're not multiplying anything. We're just adding the row 2 and row 1 elements together. So 0 plus 1 is 1. 1 plus negative 1 is 0. Negative 1 half plus 1, if you do that on a calculator, comes out to positive 1 half. 0 plus 1 is 1. 1 half plus 0 is a half. And 0 plus 0 is 0. So there's row 1. Now for row 3, we have to multiply row 2 by negative 5 and then add it to the row 3. So 0 times negative 5 is still 0, plus 0 is 0. Negative 5 times 1 plus 5 is 0. Now this one you'll probably want to put into your calculator. You have to do negative 5 times negative 1 half. So that's a positive 5 halves plus the negative 2. So get a common denominator or use your calculator. That ends up being 1 half. Negative 5 times 0 is 0, plus a negative 2 is still negative 2. Negative 5 half, or because that'd be times the 1 half, plus 0 is negative 5 halves. And then negative 5 times 0 is 0, plus 1 is 1. Okay, so that's where we're at right now. Okay, now we're moved on to, this is column 2 complete. So 1, 0, 0, 0, 1, 0. Now we just have to get a 1 in this bottom spot of where the positive 1 half is, and then clear out the zeros ahead of it or above it. Okay, so to get rid of any fraction, you just multiply by the reciprocal. So we're going to do 2 over 1, or just 2, times row 3. So I'm bringing all of my other rows over as they are. And then 2 times the whole row 3 would be 0, 0, 1, negative 4, negative 5, and then 2. Okay, so notice the negative 5 halves times 2 would just be negative 5. All right, now we're going to zero out, remember, above that 1. So for row 1, we need to do negative 1 half of row 3, to make that a negative 1 half, because remember, this is our pivot element, plus the row 1 elements. Row 2 is going to be, it's already a negative 1 half, so we wanted to zero it out with a positive 1 half of row 3 plus row 2. Okay, so our row 3 is coming over as is, 0, 0, 1, negative 4, negative 5, and 2. Now we're going to work these out. So let's start with row 1. So negative 1 half times 0 is 0, plus 1 is still 1. Negative 1 half times 0 plus a 0 is still 0. Negative 1 half times 1 is negative 1 half, plus a 1 half is 0. Negative 1 half times negative 4, that's going to be a positive 2, plus 1 is a 3. Negative 1 half times negative 5, or is going to be positive 5 halves plus a 1 half. That's going to be 6 halves, which is actually 3 if it reduces. Negative 1 half times 2 is just negative 1 plus a 0 is a negative 1. So notice we ended up getting nice answers here because the way the halves added up to made them divisible by 2. Okay, now let's look at row 2. So half times row 3, so that'd be 1 half times 0 is 0 plus a 0 is still a 0. 1 half times 0 is 0 plus a 1 is a 1. 1 half times 1 is 1 half plus a negative 1 half is a 0. So notice now I have my identity here like I expected. So we know we're going to have this being the inverse. We just have to finish it. 1 half times negative 4 is negative 2 plus a 0 is a negative 2. 1 half times negative 5 would be negative 5 halves plus a half. That'd be negative 4 halves if you use your calculator and double check that. So that's also negative 2. It reduces nicely. And then 1 half times 2 is 1 plus a 0 is a 1. So my inverse, this is going to be F inverse, is right here now. It's located. Now this one we didn't have a nice way to check by the determinant because we said that method is pretty lengthy and has a lot of memorization of sign changes. So this is really truly for us the best way to know how to find the inverse of a 3 by 3 without having to memorize a bunch of formulas because there's actually multiple variations of that determinant finding for a 3 by 3. So you use the augmented matrix, you put the original matrix on the left, the identity matrix on the right. You continue to do row operations until you create the identity on the left. And if you're able to do that successfully, the inverse is the numbers located in the right side of that box. Okay? All right, so I'm going to save this one for class just so we have one to do together. So let's make sure we look at the rest of this and see if there was anything else that we did not cover in class from 4.5. I did teach you how to find the determinant. Let's do this other one right here just so you can see this process again. So the first step is you want to say this is matrix G. Say that's my matrix. I just give them names just so I can talk about the inverse. So for the determinant, which we call capital D, you do the A and D, which is the first diagonal. We look at that. So 2 times 6. Subtract, it's always minus. Then we multiply the second diagonal together. So that's negative 4 times negative 3. This is 12 minus, and that's also positive 12, so that's a 0. So this is where we get into trouble. The determinant cannot be 0. If it is, we do not have an inverse. So since my determinant value is 0, then matrix G, which is what I named it, is singular. It means it does not have an inverse. Okay. All right. And then I did skip all of this cryptography stuff. It's no longer in the homework. It used to be. It's no longer in the quizzes or on the test. I will make maybe a video of it sometime before the end of the semester if anybody's interested or if you're in that field of study. It's just a nice application of matrices. So that means we will be, besides doing the 2 examples I have left in the notes, we will be starting here on our class. So you can write omit on all of those cryptography problems that start right here. And just make sure that you are good with the 3 different ways that we learned how to find 2 by 2 inverses. We use systems of equations. That was one way where we set it up as a system and we solved it. We learned the determinant formula for 2 by 2, which was nice and that was quick. We also learned how to use augmented matrices. For our 3 by 3s, usually the augmented matrices is the only version of that we will practice. So that concludes 4.5.